Hello students, welcome again in our video lesson. So we are doing now chapter number 7. We have done up to page number 104. The nitrogen cycle we have discussed. So today I will start from page number 105, that is from oxygen, very important component of air. We have discussed this in your online class also. So oxygen is the second most abundant gas in the atmosphere, all of you know. Oxygen is first discovered independently by Carl W. Scheele and Joseph Priestley and Anthony Lavoisier. The gas was named oxygen by Lavoisier. Oxygen is found both in free state and combined state in air. And in combined compound form, it is water, oxides of nitrates, sulfates and carbonates, so many things. Okay, now we will discuss the important thing that we have to discuss here, that is first is the preparation of oxygen. Preparation of oxygen, very important. Okay, so how oxygen is prepared? First is from hydrogen peroxide. So what we do in this hydrogen peroxide, if you decompose the heat hydrogen peroxide or decompose hydrogen peroxide, means H2O2. When you decompose this hydrogen peroxide in the presence of catalyst MnO2, that is manganese dioxide, this manganese dioxide speed up and break this hydrogen and oxygen. So here manganese dioxide acts as a promoter, that is positive catalyst. It is used to form water and oxygen. So H2O plus O2. So we have to balance here also. So it is 2 now. So here also have to give 2, 2 to 4, 4 to 4. Now it is 4. It is now balanced. So what we see here, so in this catalyst is all of you know what is a catalyst. It's a substance that does not take part in chemical reaction, but they either speed up the rate of chemical reaction or slow down the rate of reaction. So here manganese dioxide that we are using here, it acts as a positive catalyst. So we have to first take hydrogen peroxide and then manganese dioxide in a powder black, it's a black powder form. So when you heat it, hydrogen peroxide, it decomposes to form water and oxygen. So it is the first method by how we can do the preparation of oxygen in the. Now oxygen is collected in the gas jar. Okay, now second is from potassium chlorate. Next is from potassium chlorate. Number 2, from potassium chlorate. Okay, so what we have to do here, potassium chlorate, the formula of potassium chlorate KClO3. So again when you heat it in the presence of catalyst MnO2, we have to heat here. Okay, so you will get potassium chloride plus O2. Okay, now you have to balance it here also. So oxygen is 2 here, here is 3. So 2, 3 is 6. So we have to make it 3 here and put it 2. So here also 2. Now it is balanced. So what we do here, we have to just heat potassium chlorate in the presence of positive catalyst. Here also manganese dioxide. In a closed test tube, we have to do the experiment. Then the gas is released here, that is oxygen is collected by downward displacement of water. Again here also we are using downward displacement of water. Okay, so in this setup we have to use for the laboratory preparation. You can see these things in your book also, the apparatus arrangement and what we have doing for this preparation we can see here. Next is the from metallic nitrates. Third way of preparation of oxygen is from metallic nitrates. Okay, so metallic nitrates means you can take potassium nitrate KNO3. So again you have to heat it, so it decomposes to form potassium nitrite plus O2. So potassium O2 to 4 is 3, so 6. Now if you put 2 here, it also 6, that is balanced. Okay, so what we see here, when potassium nitrate is heated, it decomposes to form potassium nitrite with oxygen. This oxygen again is collected in a gas jar by downward displacement of water. Okay, another example that we given in the book, that is with a sodium nitrate, NaNO3. It again, when you heat it, you will get sodium nitrite plus O2. Now you have to balance here, here 2, here also 2. So in both the reaction what we see here, so potassium nitrates are break into nitrite and released with oxygen gas. Okay, now these two oxygen gases we have to collect in a gas jar by downward displacement of water. So in this from metallic nitrates to nitrites and oxygen, we don't need any catalyst here. In the first two from hydrogen peroxide and potassium chlorate, we need again we have to heat here also, but we need some positive catalyst. But in last process we don't need any catalyst here. Just when you heat it, you will get oxygen gas. Now you can collect it in the gas jar. So this is all about the way, 3 ways by which we can prepare hydrogen gas, oxygen gas in the laboratory. Next is the properties of oxygen, the physical properties. Oxygen has a physical properties such as it is colorless, tasteless and odorless gas. It is slightly heavier than air, so it is more soluble in water than nitrogen. It is neutral to the litmus paper, either neither acidic nor basic. It liquefies at minus 183 degrees Celsius and solidifies at minus 218 degrees Celsius. So if you want to get a liquid oxygen, you have to cool it up to minus 180 degrees Celsius, and after liquefying it freezes to form solid at minus 218 degrees Celsius. So oxygen has some chemical properties also. It is highly reactive. It reacts with both metals and non-metals to form oxide, that we have seen in the metal non-metals chapter also, how this oxygen reacts with metals for corrosion and rusting processes also. Such reaction is called oxidation reaction. Now other than these chemical properties of oxidation reaction, we can say that metals reacts with metals also to form some reactions, such as we can see that So reaction of oxygen with metals. Okay. So metals, oxygen reacts with metals to form metal oxide. Suppose Na plus O2, it gives NaO2. Okay, N2O, Na2O, sorry, Na2O, that is sodium oxide you will get. Similarly, calcium oxide, Ca plus O2, it gives CaO, calcium oxide. Similarly, magnesium with oxygen, it gives magnesium oxide. Potassium with oxygen, it will give potassium oxide. Next is the metal with non-metal, reaction with non-metals. Reaction with non-metals. Okay, so reaction with non-metals also, suppose carbon with oxygen, it gives carbon dioxide. Very simple way, simple example. Similarly, with phosphorus, it reacts to give phosphorus pentoxide, that is P2O5. Okay, so in this way we can see that oxygen also reacts with non-metals to form non-metallic oxide. After that, another is the rapid oxidation and combustion. So all these processes comes under, mainly we can say that they are slow oxidation. These are all slow oxidation. Okay, but for rapid oxidation, example is, for first one is the combustion. Okay, combustion, or we can also say that it is burning. So anything burns in the presence of oxygen, you know, that's why we say that oxygen is a good supporter of combustion. So many examples: fuel burns to give carbon dioxide, water vapor, and heat, light. All these comes under burning. Okay, so other fuels like paper burns, clothes burns, wood burns in the presence of oxygen to give carbon dioxide, water, and heat, sometimes light also. Okay, in this slow oxidation process we can see some more example. That common example for slow oxidation is the rusting of iron. Very familiar example, you have seen the rusting process in the metal non-metal chapter also. What is rusting? So here iron Fe reacts with oxygen plus water, that is in the presence of moisture we can say H2O. It gives Fe2O3 dot XH2O, that is called hydrated ferric oxide. It is also called hydrated ferric oxide. Okay, so this is a slow oxidation also. So this is the main very simple, that is rusting of iron. This is a slow process. After that, uses of oxygen. Oxygen is very useful gas. Most essential is for respiration process. Very important. It is used in oxyacetylene torch or oxyhydrogen torch for welding and cutting of metals. It is used in the manufacturing of iron and steel. In a blast furnace, oxygen is used to extract iron from its ore also. Okay. Now, next is the renewable of oxygen. Oxygen is also renewed to the atmosphere by the two processes simultaneously goes on, that is photosynthesis and respiration process. So during this photosynthesis, plant takes carbon dioxide from the atmosphere, and they release oxygen to the atmosphere. These oxygen are taken by animals for respiration, and return they give out carbon dioxide. Plants also respire, all of you know, at night, because at night plant cannot prepare their own food there because there is no sunlight. In that time, what plants do? They take oxygen from the atmosphere and they oxidize it, the stored food, to produce energy and carbon dioxide, and they release carbon dioxide. So by these two processes, mainly the respiration process and photosynthesis process, the oxygen and carbon dioxide cycle goes on. Okay, so these are very important. So in this way we can renew oxygen into the atmosphere. Okay, so very important. This is about the oxygen in this chapter. The next video lesson we will see about carbon dioxide and uses. Again we will see its properties also. So thank you students. See you again in the next video lesson. Thank you very much.